All right, so here we go with
last
lesson 4.
lesson here for trig
This lesson is
equations,
about
unit
first
9, so
degree
last one
trig
before our
equation.
quest. Lesson
In
5
other words,
is
we're
just
going to be
solving
solving
second degree
linear
trig equations.
So now,
that
instead of
happen to
linear,
have
we're thinking
trig
quadratic
functions in them.
trig equations.
So when solving trig
we're still going to be doing
equations,
a lot
we
of the
are
same
basically
stuff
going to
from
be
last
using
lesson,
known
one,
information about the
linear
ratio that we
guys, where
have.
we
So
have to
that's
isolate the
lesson
function,
3
find our quadrants, and so
to
on.
determine
But
all
now
of the
we're going to be
angles
having
that
quadratic
satisfy our
equations
equation
in the first place,
in a given interval.
which we're going to
So
still solve
sometimes
the
the
same
interval
way
might be
by setting
from
them equal to
0
0
to
and
2
trying to
pi.
factor them.
It might be
There's just
all
going to
real
be a trig
numbers.
function in
So
there.
you have to
It's
pay
going to look a
attention to
little
that
funny.
in addition
We might be
to
making
solving for
substitutions
the
for the
particular
function
angles,
itself, and
that
then
might be just from 0
resubstituting
to
it back
2 pi.
at the end.
So I've got
But,
the steps written out
the
here
steps
for
are
you
more or less the same.
to solve our functions.
So again, just like with
to
first
solve our
degree,
equation,
they might
what
be
we'll
over
do
a
first is
specified interval,
isolate your trig
or
function.
they might be general solutions.
And then from last
Let's
class,
look
we're
at
going to
example
determine
one.
the quadrants
I've
where
got
we end
2
up using our
cosine squared
ASTC
alpha
rule. So there's going to be
equals
2,
root 3
either
times
positive or
cosine
2 for negative,
alpha.
depending what the
And
function
notice
is.
the interval
Then you're going to
for
find your
this
reference
one is
angle,
from
so
0
that's
to
going
2
back
pi.
to lesson 2.
So we're just looking in that area.
And then last but not least,
Okay,
we're
this
going
is
to find that
quadratic.
standard
Now,
position
you
angle
don't
and
have to
then
do
look at
this,
the
but at
interval
first you
and
might want
report
to
whatever
do
the
a
appropriate
substitution.
angles are.
I see cosine
So
alpha
mostly
and
in this
cosine
lesson, we're going to
alpha.
look at
So
different
instead of
examples
that,
and
let's
what
say that
they will
x
be.
is representing
So
cosine
example
alpha.
1, we're going to find
So
the
instead
angle
of
and
having
note
2
the
cosine alpha squared, I'm
interval
gonna do
here
x
is just
squared.
from 0 to 2 pi. So
Equals
this is
root
the
3
easy one when you're
times
just in
instead of
one
cosine
full
alpha
rotation
x.
of the circle. And this is
And
the
I see
most
that
common
quadratic.
interval to deal
Now,
with.
to solve any
So
quadratic
what they tell
equation,
me,
we wanna
the
set it equal to
equation is
0.
that sine theta equals
move the
negative
root
root
3x
2
to the
over 2.
left-hand side
So the
here.
first step
And
would
I'm
be to
gonna factor
isolate
it.
that
So
trig
I'm gonna
function.
pull out an x
Happens to already be done for us. So what I would do next is I would draw my
So for
quadrants.
this quadratic equation,
And I'm
I
going
would
to
have two
determine
solutions.
which
X
quadrant
equals
am
0,
I in using my
or
AS
2x minus
TC root 3
rule.
equals 0.
Okay.
Sine is
So
negative
solving that's not too bad. Now I need to go
which
back and
means
replace the
that
fact
I'm
that
in
x was
not
actually
in the
cosine
A
alpha
quadrant because that stands for all
So
positive.
what I need to
and
solve
not
now
S
is cosine
quadrant,
alpha
'cause that's
equals
for
0,
sine positive.
and
So
2
sine is negative.
cosine
So what I'll do here is I'm
alpha
going to draw
minus root 3
a triangle
So now
the
what I've
reference
done is I've
angle, so
split it up into
x-axis,
two little
in
linear
quadrants
equations.
3 and 4.
So these are separate
that's where
questions
my
that are
angles
part
would
of
be
the
that
same
I'm looking
solution.
for.
Now
So what
let's
I
solve them
can also
individually.
do
The one on
using
the
that
left,
ratio
cosine alpha
is
equals
fill
0.
in the
That's a
sides of my
quadrantal
triangle,
angle, so that's one of the weird
because
ones.
sine ratio we know
Cosine
is
is
opposite
0.
and hypotenuse.
Maybe you remember from
so the
last
opposite
class,
side of
whenever
each of these
x
triangles
is
is 0.
relative to the
So it's
reference
gonna happen
angle
here, and
will
it's
be
going to
root
happen
2.
here. So
And
I'm
the
going to have two
hypotenuse will be
solutions
a
for the first one.
Alpha.
Now notice
will
that they're
be
also going in the negative y
90
direction, so I
degrees or
should
pi
really
over 2
include that
since
as
they're
negative
negative
root 2
radians.
going down.
And it will also
All right,
be
so I need to
270
determine what the
degrees.
reference angle is
3
here.
pi over 2.
Now I can do that in a number of
So
ways.
that's the first one.
You
Those are
can
two
just use your
solutions that work.
calculator if you want.
The second
by
one
doing
is a little
inverse
more work. Here I
sine
need to isolate
of
the
your
cosine
angle.
I've
already
function.
accounted
So
for
I
the
get
fact
root
that
3
it's
over 2 on the
negative,
other side.
so I'm just going to
And then this one's not
forget about
quadrantal,
that
so we
because
can draw
we've
it
already
like
used
normal.
that to find our quadrants.
Cosine positive,
Okay.
so that's telling
So if
me
you
I'm
do that
in
in your
quadrants
calculator,
1 and
it
4.
should tell you, depending on the mode
And
that
I
you're
see
in.
that the adjacent side is
Sorry,
at
I'm
root
just doing
3,
it off to the
and
side
the
here.
hypotenuse side is at 2. So this is the 30, 60, 90 triangle, which tells me my reference angle is
It
the
tells
30
you
degrees
0.785
opposite the 1,
radians,
or
but if you
pi
happen to
over
be in
6.
degree mode, it tells you 45
So to find
degrees,
two other
which
solutions,
means that this is
I get alpha
the pi over
3,
4 special triangle,
which is in
Now, you
quadrant
might not
1, so it's just
see
the
that
same as the
because each
reference
of these
angle,
sides
5
has
over
been
6.
multiplied by
And
alpha
4,
which is in the fourth
root 2,
quadrant, so that one will
right?
be 2
This
pi
would normally be the
minus pi over
45, 45,
6,
90,
or
which would have
11
1, 1. Okay, so this particular question has
And if I
4
multiply each
solutions.
side by root 2, all of those
What I
guys,
see
and you can
is
check them all in your calculator, the
put it in
ratios
radian
that we
mode,
have in this
plug each
particular
one in
question.
to the original equation.
So what that means is that
So
the
I plug
reference
in
angle for this
2
question is
cosine
pi
pi
over
over
4. Now I'm
2
going to use that to
squared,
find my
and
two
then I would
angles
plug
that
in
I
root 3
want to
cosine
find,
of pi
namely the
over 2,
standard
and I
position,
would see
this
if
one
there
and this
is.
one.
And you
I'm
can
going to
check
have two
each one.
solutions. One of them will be
So
in
example
quadrant
2,
3.
again, I
It will
see
be
that
pi
it is
plus pi over
quadratic.
4.
I've got the degree 2 there. The interval
is
this time is
5
in
pi over
degrees
4.
from 0 to 180.
And I'm
So,
going to have a second one in
I've
the
got a
fourth quadrant,
quadratic, which
will be 2
means pi
I'm gonna have to
minus pi over
factor it. You might wanna do that
Which is 7
substitution
pi over
again.
4.
So those are
For
our two
sine,
solutions,
since I've got sine
because
squared
the
here and I've got a
interval
sine
for this
here.
question is
So
just from
instead
0
of
to
talking
2
about
pi.
sine squared, I'm going to
Done.
talk about
And you can
x
check it in your
squared
calculator just by
equals
plugging it in. Make sure you're
3x minus 2.
So let's look at example
So
2
turn that
here.
into something
This time we're
familiar.
solving
Set it to
this
0.
equation.
So let's
Secant
move
beta
everything to the left here.
equals negative 2.
And then I'm
And
gonna
again, we're
factor
from
it.
0
So
to 2
add to
pi.
negative
So
3,
that's the same interval as
multiply
what we
to
just
2.
saw. Now secant is one of those reciprocal trig
So I have
functions, and
two
they're not very nice
solutions.
to work with.
X
So
equals
instead of
2
talking
and
about
X
secant,
equals
I would
1.
talk about cosine.
But remember,
here,
X was actually
which is his
representing
reciprocal
sine.
friend. And I'm just going to flip over the -2. So 1 over -2 or negative
So
half.
those are the solutions.
And then
that
I'm
we
going to
need
solve it
find now.
exactly
So
like
a
we
little
just
more
did.
work.
So I would first of all
Sine
start by
x
finding
equals
which
2.
quadrants is
So that's
cosine
saying,
negative in.
if I want to
So
solve these
cosine
guys
is
separately
negative
again,
in
like last
quadrants
time.
2 and 3.
This is saying
I'm
that the
gonna draw my
opposite
triangles
is a 2
straight to the
and the
x-axis,
hypotenuse
just
is a
like
1
last
by
time.
default. Now this is
Okay.
saying opposite
This
side
side
is
for
bigger
cosine
than the
adjacent
hypotenuse side,
over hypotenuse.
which is not possible.
So I'm
because
going to
the
fill in
definition
those
says
sides on my
hypotenuse is always the
triangle. So
largest.
adjacent here
So
will
that
be
just means
along
that
the
this
x-axis,
particular
negative
part of our
1, and my
question
hypotenuse
gives
is
me
a
no
2.
solution.
This one's a little more
Which is fine.
obviously.
Let's just move
It
on to the other one.
is the 36.
So the one on the right, sine x equals 1, that's a quadrantal
this is 2,
angle.
this one's got to be a root 3.
It's saying that the
so my
opposite and
reference
the
angle in there
hypotenuse are equal. So if you think
is
about where
60
that would
degrees
happen,
for
opposite and hypotenuse are equal.
Okay, so you
that's
gotta know
the
those
y
special
and the
triangles
hy-
pretty well.
And the hypotenuse are equal.
So to carry
That's gonna
on, we're
happen
almost
here.
done here. We just have to
And
find the two standard positions.
So we would have
oops,
two
I shouldn't use
solutions,
theta here, I should use
90
beta,
degrees
yes.
and 270 degrees.
So beta 1,
But you
beta
have to
2,
pay attention to
I'm
that
going to
initial
find the one in the
restriction,
second quadrant, pi
which
minus
was from
pi
0
over
to
3
180
equals
only.
2 pi
So
over
anything
3.
down here I actually don't
And the
care
one in
about
the
because
third
that's not
quadrant,
in
pi
my
plus
interval.
pi over 3.
So I only have one solution
Which
for
is
this
4 pi
question,
over 3.
which is
So for this
90
question, those
degrees.
are our two answers. You can plug them into
And
your
again, you can
calculator,
check it
right?
by
We can't plug
plugging
secant into our calculator, but you can plug it
Okay,
into
example
some. You can
3.
check it that way.
Solve
Okay,
over
so
the set
note
of
here,
all
when
real
solving
numbers.
for an
So
angle,
again,
ignore
this
the
time I want a
negatives, right?
general
That's taken
solution,
care of by
and
our
they want it to be
quadrants.
in radians.
Once
It's
you've found the
specified
quadrants,
here.
you can almost
I see
forget the
tangent,
negative
and I know that
altogether.
it's
Then
quadratic.
make sure
so
that we're
let's
using
do a
exact values,
substitution
right?
again.
We always want to be as
Now, once
precise
you
as
guys
possible.
practice this lots,
So
you don't
example
have
3,
to do the substitution.
This time I have a
It's
little
not
bit of work to
necessary,
do.
but
First thing I need to
sometimes
do
it
is get the
helps make some
tan
sense of the question.
theta all alone.
So what I'm
just
going
by
to solve
isolating
it first
it.
is x
So
squared
subtract
minus
5 to the
5x
other
plus
side
4
and
equals
divide
0.
by 3. I get negative
Accurate.
5/3. And notice
So
our
this is
interval
x
here from
minus
0 to
4x
360.
minus
So this
1.
time I'm going to answer
So
in
x equals
degrees
4
because the
or
question
x
is in
equals
degrees.
1.
Okay, I'm going to figure
And now I
out
need to go back and
quadrants.
change that
So
to tan.
tangent
So
is
tan beta
negative
equals 4
in
or
2 and
beta
4.
equals 1.
So there are
And
my
then
two
solve.
triangles, same as always, referenced
Okay,
to
so the first one is
x-axis.
saying
So those are my
opposite
reference
is
angles
4.
there. Okay, this
Adjacent
time
is
I've
1.
got tangent.
So that's possible.
So that's
So let's
opposite
draw a
divided
picture of
by
what this would look like.
adjacent. So the
So
opposite
tangent is
side from those
positive
reference
in
angles here is a
quadrants.
5.
1
And the
3.
adjacent side here is a 3.
Here.
Now
And in
notice
this
that the
case, our
negative doesn't
opposite side
necessarily belong to the
relative
5.
to our
Look at your
reference
picture
angle
and
is
you can
4.
figure out which side is negative. So
And our
for the
adjacent
second
side
quadrant,
is a
it's
1.
the
And
3
notice
that's
that
the
in
negative,
quadrant 3 they're
and in
both
the fourth
negative.
quadrant, it's the 5
Okay,
that's the
to
negative.
find the
But
reference
honestly, that
angle
doesn't
here,
really
it's
matter
not a
if we're just
special
looking for the
triangle.
angles.
So we do have to use our
Okay, so next thing I need to do is find my reference angle. Now, for
So,
this question,
inverse tan.
this is not a
of just
special
4.
triangle.
So when you do that in your
So
calculator, we
to do
want
this
it to be in
one,
radians.
we're just going to resort to our
Since the
calculator.
or the
That's what
question
we're stuck
said
with.
answer
Make
in
sure you're in
radians.
degree mode.
So
Okay,
inverse
because
tan of
otherwise we're
4
going to answer in the
radians
wrong
gives me
unit for what the
1.325.
question asked.
So
So in my
let's say
calculator, I'm going to do inverse
1.33.
tan. I'm going to forget the
So
negative.
that's the
because I've
reference
already
angle.
taken care of that.
Okay, so
of
see
5
that we've
thirds.
got two solutions here.
And
Beta
what I
1
get is 59
is
degrees.
1.33 in the first quadrant.
Okay. So I'm going to use
And
that
in
then
the
to find my
third
final answer.
quadrant,
I'm
I've
going to
got
find
1.33
theta 1 and
plus
theta 2. There's two
pi,
answers
which
here.
is
in
4
my
point
interval.
47.
The first one will be 180 minus 59 degrees.
So two
Which
solutions in
is
that
121.
in that interval. Now I know
And
this is
the
a
last
general
one will be
solution, but we're going to
360
deal with that at the very
minus
end of the
59
question.
degrees.
Okay, let's go on to
Which
the
is
other
300.
part. So I've got tan equals
Again,
1.
check them
so
in your
that's
calculator. Take that
opposite,
extra minute to do
and
so.
that's adjacent. So
Okay,
let's
so
draw the
flipping over to the
picture.
back side now.
Tangent's positive,
On the
so
top
we're
here,
in
there's kind of a
quadrants.
funny concept
And
that
3 again.
really isn't all that
And this
different
time our
than
opposite
any of
is
the
a
other ones
1,
we've talked
and
about.
our
It's just a
adjacent
sort of
is a 1 as
specific
well.
case.
So this one is a
of
special
some
triangle.
of the sine,
This one is the
cosine, and
45,
tangent
45,
ratios.
90 triangle.
So they're called quadrantal
reference
angles.
angle here is
Reason
pi
is
over
because they're
4.
on the quadrant.
So
So
this
the
time I
angles
get
terminating
two
on
more
the divisions
solutions.
between any two quadrants.
Pi
The
over
ratios
4
for these guys
in the
are
first
always going to
quadrant,
be
and
any of
5
these
pi
three,
over 4
0, 1, and negative
in the
1.
third
And it's
quadrant.
helpful to be familiar with each
So those
one.
are specific solutions.
So we'll fill in
They
this
wanted
picture.
a general solution.
What we're going to do is
So we
go
need to
around
combine everything.
the circle.
Now to find the general
and stop
solution, you're
at
really
each
just finding
quadrant. So we'll
coterminal
start
angles.
right
So
on
I
the
could take
positive
all
x-axis.
4 of my
In other
answers
words,
and
at
just
0
add
degrees
2
or
pi
0
n.
radians.
That would do the job.
At this
Okay.
position,
Instead of
no
that,
matter
since
where
it's
I
tangent,
stop,
I noticed that
the
it
y
rotates
value
every
is
half
0. I
circle
haven't gone up or down at all.
for each
And the
solution.
x
So I
value
can combine
is
them
the
into two
same
separate
as the
statements, one for
radius
the one on the
of
left
this
and one for the
particular
one on the
circle.
right.
Okay.
So what I would say is that theta
So
1
we can use that
is
information then to come up
1.33
with
from my first
the sine
answer
ratio
plus
of this
pi
angle,
n.
the cosine ratio,
So that's of this
everything on the
angle
left,
and the
because
tangent
the
ratio
pi will give me each half
of this
circle
angle.
rotation. Because the sine ratio is opposite,
The one on the
which is
right
the
would be
y
pi over 4
divided by
same thing,
the
plus pi
hypotenuse,
n.
which is the
Okay, and that's going to give
so
me
if you
all
want
my
to note off to the
solutions,
side
every
here,
half circle. And I should say here
x
for both of them,
is
but n is
usually
just any
going to be our
integer.
adjacent side,
And that's
y is
everything.
going to be
That's all
our
four.
opposite
If you did them
side.
separately, that wouldn't be a
R is gonna
problem,
be our
but it looks a little
hypotenuse
nicer like
for
this.
trigonometry. So the
Okay,
sine ratio
so let's
then
flip to the
will
back.
be y, which is
We've
0
got just a
divided
couple
by
more
r.
examples here.
So I get 0.
So for
The
example,
cosine
for
ratio
A,
is going to be
we've got
x,
secant
which
of
is the
2
same
theta
as
equals
r,
2.
which is
We're going to do it for
divided by,
all
so
real
x
numbers, the
divided by
general
r
solution, and we're going to
gives
answer
me
in
1.
radians. Now for this question,
And
we've
the
got
tangent
something we
ratio,
haven't
which
seen
is
before.
opposite, which is
2
0
theta.
divided
We've got a
by
number
adjacent, which is
inside
whatever it is,
with the
is gonna be
variable.
0.
Now this, you guys,
So I
should
see
consider
that at
untouchable.
0
You
degrees,
can't divide by
sine
2
is
to
0,
simplify an
cosine is
angle,
1,
for
and
example.
tangent is 0. So
Okay.
those ones are a little bit
So we're
funny
going
and
to do
they're nice to be
substitution
familiar
here
with.
as well. This is
Let's
not a
keep going here. I'm gonna
quadratic
pick up the
equation,
pace a bit.
but it
At
is a
90
different
degrees,
type. What I'm going to
what
do
I
is
have
I'm
here
going to
now
say,
is that
let's
x
say
is 0
x is 2
and that
theta.
y and r are the same.
And
So
then,
when I
instead
go
of
through the
solving
ratios,
secant 2 theta,
same
I'm
as
going to solve
before,
secant
what I
x,
find for
which is
sine
something
is
I
that
know
the
about.
y and the r are
That's
the
familiar.
same, so I get 1.
Right, so going back to last
What I find
lesson,
for
instead
cosine
of
is that
doing
x is
secant,
0,
I'm
so
going to do
cosine is
cosine
0.
of the reciprocal, 1 over 2.
Tangent,
Draw your picture.
this
Cosine
one is going to
positive
be
in
the
1 and
opposite y
4.
divided by the adjacent
Okay, the
x, which is
adjacent
0.
side
So
here
divided by x
is a
is
1,
undefined.
and the hypotenuse side here is a 2.
So I can't have that one.
So
for
this is
tangent.
the special triangle, 30, 60,
Okay, keep
90.
going
My
around the
reference angle
circle
is 60
along the
degrees.
negative
pi
x-axis.
over
Here I've got y
So I would
0
get two
again.
solutions.
And this time x and r are the
in
same, but they're the opposite
one full
sign.
circle,
So I
but
would
they
say that
want all real
negative x
numbers,
is
so
the
we'll
same
deal with
thing
that
as
in a
r.
second. So I would get theta 1
Sine ratio
over
here
3,
will be 0.
theta 2
Cosine
would be
ratio
2
here
pi
will be
minus pi
negative
over
1
3.
since they're the same but opposite sign. And tangent ratio
Or
here will
5
be 0. So notice how they're almost exactly the same as the
But the
positive
question wasn't
x-axis,
asking me
except
for
the cosine
theta.
has the
They
opposite
were
sign.
asking me for x.
And then
Right.
last one
And
at
I
the
have this
bottom here,
statement
I've
which
got
helps.
x is 0
So I can
again.
see that
So
instead
along
x
the
is actually going to be
270 negative y
sorry,
axis.
not x.
X is 0 and
I'm
y and
confused
r
now.
are equal again except opposite
Sorry,
sign.
this is x,
So
not
here
theta.
what I'll
So-
have, sine will be negative
Because that's what
1
I was
now,
solving
since
when
they're
I
the
did
same
my
but opposite
substitution.
sign. Cosine
So sorry,
will be 0
what we're
again,
actually going to try to
and
find
tangent
is
will be
theta. The
undefined.
question has a theta in it.
Okay.
So I need to isolate
in these
this little
cases, if I have a
substitution I did
ratio
for
like
theta.
0, 1, negative 1, don't try to draw a triangle.
And I can see
because
that
there isn't
theta,
really a
if I divide
triangle
by
to
2, is
draw.
x over
It's on
2.
a quadrant. So just
So
watch
if I'm
out for those
solving for
guys.
theta, what I'll
Okay.
do
And then the
is
last
I'll
thing
take
for
the
this lesson
solutions
is
that
called
we had a
general
second
solution.
ago,
So
and I'll divide
sometimes
them by
instead of
2.
stating within a specified domain, we can state a general solution. So just
Okay.
like we did
Division
with
of 2,
coterminal
same thing as
angles,
multiplication of a half.
These
So
guys
this
are
is
all
pi
going
over
to
6.
repeat every
This is
full
5 pi over
circle.
6.
So what we'll do is just add
So those
2
are
pi n
specific
at the end,
in
telling
the
that n is an
interval from
So
0
last couple
to
examples.
360,
Example
but it's
4,
actually not
solve
from
sine
0
x
to
for all
360,
real solutions. This
right?
one's fairly
Since our
straightforward.
interval
Sine
has
x
been
equals 0
divided by
is one of
2,
the weird ones.
this is
the
actually
quadrantal
only
angles.
solutions
So think about what this means. 0
from
on
0
top
to 180
means that
degrees.
the
Since we
opposite side
divided
is
by
a 0.
2.
And on
So
the
our
bottom
final
here,
answer
you can
for
always
general
default to 1.
solutions
If there's
will
nothing
be
there,
the one
throw
we
a 1
have,
there.
pi over 6,
But mostly
and
what's important is that the
5 pi
opposite
over
side
6,
is a 0, which means that the
plus
y value
not
is
2
0.
pi n here,
So I haven't gone up
because
at all.
they've
So I'm
divided
here,
the whole
or maybe
circle in a half
I'm here.
because of that 2 theta in
So my
there.
solutions
So
then,
instead
I
of
can see
adding
them
2
right
pi
away.
n,
I
I'm
don't
just
really
gonna
have to
add
do
pi
much
n.
work. I would say that x1 would be 0 and x2
because
would be
of that
180
change
pi.
in the
Now, they want
angle
all
there.
real
So
solutions.
the whole thing
every
gets
single
divided by
one.
2, the full circle
So
as well.
I can do one of two things here.
So that's
I
that
can
one.
just
Let's
take
try
the
another
two
one like that,
solutions
'cause
I
these
have
guys are a little
and
bit
add
trickier.
2 pi n.
So there's our answer.
Add 2 pi n.
So for option
and
B,
say that
if
n
you
is
want
an
to pause
integer.
and try it by yourself, this might be a
Or
good time to do
for
it.
this question, I can actually
Okay,
condense
so here
it
I go.
into
I'm going to
one
do my
final
substitution. substitution. Since this thing repeats,
So I'm gonna say, let's let
every
x
half
equal 3
circle,
theta. So what I'm doing is
what
I'm
I could
taking
say
everything
is
and I'm
that
actually
this particular answer
condensing it.
would
'cause
just
if I
be
want theta, I'm
pi
gonna take whatever I
n.
get and divide it by 3.
Where n
Not
is
just
an
my
integer.
specific
So
solution,
that's just
but the
meaning
general
a
solution. the whole thing.
rotation of half circle
Okay.
pi.
So I'm gonna
if I
solve
plugged in
tan
n0,
x
I would get that 0 degrees.
equals negative
If I
1.
plugged in n1, I would
So
get
this
the
is
pi.
negative 1 over
If
1.
I plugged in
My
n2, I
opposite
get
is
2
negative
pi. my
and so on,
adjacent
and I'd
is
get all my
positive.
solutions in there.
So tangents negative. Example
So that
5,
puts me
solve
in
tan x
quadrant
equals 1
2
for all real
and
solutions.
4.
So again,
My ASTC
let's think about
rule.
this one. Now this one's a little bit tricky. When you think
Opposite
about tan
side here
x
is
equals 1, so
Adjacent
isolate
side here
the
is
trig
1.
function,
This
that's
one's
already
negative,
done.
this one's negative.
Now, this one
Okay,
is
so
not
to
one
find
of
my
the
reference
quadrantal
angle,
angles.
in
In
this
this
case,
case, we've got a special triangle.
This
If
is
I
saying
didn't,
that
I'd
the
use my
opposite is
calculator.
1.
So
The
theta
adjacent
r
is
here,
1.
this is the 45,
This is
45,
actually
90
an
triangle.
isosceles triangle.
Or
We can
pi
draw
over
it.
4. So let's think. Tangent's positive, so I should
That's gonna put
really
me
make sure
in
that I use the
quadrant
right
1
variables
and 3.
here. This
So I'm here
particular
and I'm here.
equation is solving for x, not
Okay.
theta. And
So
the
I've got
opposite
two
answers
hypo-
here,
or sorry, the opposite
x1
and the
in the
adjacent,
second
they're
quadrant
both
will
one.
be pi
Down here
minus
they'd be
pi over
negative
4, or 3
So
pi
this is
over 4.
actually the 45, 45, 90
And
special
in
triangle.
the
Right?
fourth
This one
quadrant,
would
it's going to be
root
2 pi minus pi over 4,
root 2.
or 7.
So theta r here is going to be 45
But we don't want
degrees.
x, of
They
course,
didn't
we
tell
want
me
theta.
which units to give, which is kind of annoying.
So I'm going to find theta
oh well.
1 and theta 2
Pi over 4,
by taking the
let's say.
solution
Or
that I've got
45
there
degrees
and
if you want.
multiplying by a
Maybe
third.
22.
Same thing as dividing by. So to find my solutions, I'm
To
going to
adjust.
find them in each of those quadrants. In the first quadrant, it's whatever the reference angle is, pi over 4. So the first
In the
one, 3
third
pi over
quadrant,
12,
plus
or
pi
you
over
can just
4,
see that it
which
turns
is
by
into
pi over 4. You can see it visually too. It's taking this
Okay.
angle and
Now,
splitting
since they
it
want
into
all real
one third of
solutions
itself,
here,
I'm going to add
which
full
makes sense.
circles. So
And
2
for
pi
the second
n,
one,
I've got 7 pi over 12.
2 pi n, where n is an integer.
So those are the
But
specific
again, you can
solutions
combine them
in
this
one
time,
rotation, which is
nice to
actually
do.
only a third of a
Final
circle
answer is
now.
always nicest
So
if
to
you
find
can.
my general
Since this one
solutions,
spins
what
every
I'm gonna
half
do
circle
here
as
is
well,
take my solutions.
it's just offset a
I'm
little
going to
bit.
add not 2
Every half
pi,
circle I've got myself a
but
solution.
2 pi
So what I would say
divided
for
by
a final
3.
answer for this one,
Since I had
is
that
that I would
division
start
of
at pi
3.
over 4,
And I'm going to do it, and I
sorry,
would
times
add,
n.
and
half
I'm going to do it for
circles,
both
which
of
is
these
pi
guys.
times n.
And that's everything.
Okay, those are all your answers.
N is an integer number.
Okay,
And
so
for this
that's it.
particular
The
question,
homework
you
for this
could
one is on the
condense
first
it
worksheet,
into
just question
one
1 to 20
statement.
is
I'm
practicing
going
the
to
linear
jump into this
equations.
space here. Or, since this one is tangent and it rotates every half circle, you could combine this into one really nice answer with pi over 4 is your starting place, plus half of our full circle, which is 2 pi over 3 here. So half of that is pi over 3. And that could be your final answer as well. Either this one, oops, or this one. They would both be great. Okay, very last one here. I've got sine x, tan x minus sine x equals 0. So notice that this is not quadratic. I'm not going to factor it. This is not the type where I'm going to do a substitution because the angles are just x. That's no problem. But I still can factor this guy, right? Notice that I've got a GCF here of sine x. So if you wanted to format this differently, this is the same as x times y minus x. Right, that might look a little more familiar. So what I'm going to do is I'm going to pull a sine x out. When I do that, I'm left with tan x minus 1 equals 0. Oh, my battery's dying. Okay, so now I can solve each of those separately, just like we've done before. Okay, so the one on the left, sine x, that could be 0. And the one on the right, tan x, that could be 1. And those would both give me very good solutions. So the one on the left, sine x equals 0, that's a quadrantal. So this is saying that the opposite side is 0, right? So that's the same thing as saying that the y value is 0. So I'm at the y-axis somewhere. Oh, sorry, no, that's backwards. My mistake. On the x-axis somewhere. Things beep at me and then I lose focus. Okay, so we're there. So I have two answers in one circle here. I would have x1 equals 0 and x2 equals pi. Okay, this question wants a general solution, so we'll do that at the end. Let's do the one on the right. Tan x equals 1, so that's 1 over 1. So my opposite and my adjacent are the same. It's going to be an isosceles triangle. Tangent's positive in 1 and 3 using the ASTC. So this is 1, this is 1. These guys are negative. My reference angle is pi over 4. So that gives me two solutions, x3 and 4, pi over 4, and 5 pi over 4, right? Pi plus pi over 4. So if I was just from 0 to 2 pi, I would be done. They want general solutions, so I can combine the ones on the left and I can combine the ones on the right since they're half circles. If you don't want to do that, you would just take each of your 4 answers and add 2 pi n. That would be fine too. So I'm going to have two solutions for my general solution. The first one would be the one on the left, which is just pi times n, or you could say 0 plus pi n, same thing. So pi n, where n is an integer. And the one on the right, which is going to be the pi over 4 plus pi n. Again, n is an integer. And that's everything. That's all 4 of those guys plus 2 pi. Okay, so for the homework for this one, it's the same worksheet as it was last day, except just the second half, so 21 to 34. Okay? Good luck studying.